Okay, so this diagram, once again, just to put things in context, we're now, didn't do anything. We're now at number 2 on machine learning tools. So we've moved from, in the wrong order, from storytelling, where we were talking about dissemination, and we've backed up to processing workflows and specifically machine learning. And the idea here, all of these have to do with tools that support users of data. A little question here to help me know whether, well, I guess basically whether there's any interest in this in the room. How many people do machine learning research? Huh, that's not too bad. And how many of you have constraints in accessing the processing capabilities you need, i.e. GPUs and storage, and so some interest. Okay. And how many people would like to do machine learning but don't, and maybe because they don't have access to the necessary processing? Anybody would like to get into it? Okay, that's better than I might have hoped for. So, by way of context, if you remember my last presentation, I slipped in storytelling in terms of our dashboard. I'm now going to talk about machine learning in the context of a research platform we have called Polar TEP. TEP stands for Thematic Exploitation Platform. This is a creature of the European Space Agency. Back now, we might be talking 7 years. They were among the first who realized that the volume of Earth observation data was so large that if people started to download it all, it would break the internet. And so this was a novel idea that they would bring people to the data, people would do the processing in the cloud, and the results would be much smaller than the input data. And you would save the internet. Everybody else in the world has come to that realization, so data processing platforms are not all that uncommon now as they were when we developed this. So we provide a working environment where you can access algorithms, you can bring your own algorithms, but you've got access to huge amounts of data. We're talking the Earth observation data we have access to is, well, it changes every day, but I think we're getting close to 100 petabytes of data. And you've got computing resources. For machine learning, we have access to GPUs. We spin these up in the cloud, so in theory, it's infinite computing power. We're not talking supercomputers, Lumi, that sort of thing, so we don't tend to get into large language models that need a different type of computing, and other tools. So that's what I'm going to talk about. In general, we give data access, data preparation, so we have a lot of analysis-ready data. Don't start, if you can help it, doing your own data prep. Obviously data processing and analysis. I've already talked about dissemination. And tomorrow I talk about reproducible science, open science. So we've got a bunch of things, data discovery and visualization, Python. Most of our users use Python. We could theoretically support other languages. We tend to work in Jupyter notebooks. Once you've done your coding, you've tested your code, we can move out of Jupyter notebooks into an execution environment if you're doing really, really large processing. I'm going to talk about machine learning. So, I mean, you can do whatever you want machine learning on our platform. We provide something called MLflow, which is a tool which helps you through the whole life cycle of preparing your code, testing it, revising it, etc. Just give you an example of one use we had. I will say that of all of the tools you see in Polar TEP, this is our most popular one. People seem to be, I think this was mentioned earlier, machine learning is a thing. All the funders want you to give you money to do machine learning, so there's one reason to do it. A lot of our users involved in sea ice. This was sponsored by ESA to get people outside of, excuse me, outside of the sea ice community, maybe coming from other aspects of machine learning, to try to do automated processing of synthetic aperture radar imagery to try to get ice characteristics out of it. There's a workshop on Friday where we'll talk about all of this in a lot more detail. 121 teams registered. 42, we offered Polar TEP. They didn't have to use Polar TEP. 42 did. They spent 3,912 hours of processing time on both CPUs and GPUs, depending on what they were doing. 6 of the top 10 teams used Polar TEP. And the winning team was from University of Waterloo. They actually didn't use Polar TEP because they had their own internal computing resources, but I mentioned them because that was my undergrad university. So MLflow. How many people use MLflow? Anybody? Okay. It's open source. We try to promote open source code. Supports the full life cycle of machine learning. So getting your models in order. Well, I'll go through all of this, so I won't get ahead of myself here. You can use it internally within Polar TEP. But if you want to, in the spirit of open science, publish your results, publish your models, and publish, we really like seeing training data published, because training data is the big constraint in any machine learning. There are other ESA-sponsored mechanisms to do that, and here the Earth Observation Training Data Laboratory, so we work with them. I'm going to go through the rest of this somewhat quickly because it's best to come and talk to me. If you're not interested in machine learning, this is going to be really boring, and if you are interested, I'm not going to do it justice, so I'm sort of caught in the middle here. This is a notebook that gets you started in using MLflow. So we've got lots of support for new users. There's sort of a hierarchy of how MLflow works with things. So at the top, there's this idea of projects. You'll recognize some of these terms like Docker containers, Conda environments, etc. This is probably the most important thing, is this idea of models. So this is your code. It supports lots of different things, but the big ones are TensorFlow and PyTorch. Kubernetes to manage the processing, Docker containers. Yeah. That's what the I was going to do this live, and I thought that was just going to be too painful. So these are just random screenshots. This is what the models look like. You could have different versions of a model. Then once you've got a model or your versions of the model, you're going to want to run experiments, which is this idea of you're putting different parameters in. testing to see how well it runs and seeing what you should change to make the model work better. So there's a bunch of runs, and most importantly, MLflow will automatically, you can do it automatically. You can also go in and change this to be exactly what you want, but it will automatically put code in, which will track your variables and the results, and you get nice graphs out about how well the model's working on that particular experiment, allowing you to tweak things. And then there's a model registry, which allows you to share your models with others and keep track of them. It's basically a database of models, which looks like that. And that's how you get to it. So that, I realized, was a really top-level, fast overview. I think the fundamental message is we're open to users. GPUs are not cheap, but we can get support from the European Space Agency, so the cost to you can be zero, at least for a while. And let me know if you're interested.
Nice, thank you. Does anyone have any questions? Oh, no. Can we pass that?
Sure. Hi, I'm wondering if you've got any sort of cost controls in place in the MLflow system. Like, how do you stop someone racking up a massive cloud computing bill, or is that not a concern for you?
Well, yeah, obviously it's a concern. So the accounts have limits, and if someone's bumping up against the limit, we interact with them and talk to them, and if it's justified, we can up the limit. The compute time isn't maybe I think where we would start to worry is if people are downloading huge amounts of data, their egress fees, the ingress fees tend to be zero, but the egress fees can be high. So.
Yeah, we've looked at setting up a similar system at the Australian Antarctic Data Centre, and it really just ultimately just comes down to how can we make sure that we don't spend more money than we have in our government budget.
Well, so have you had problems of that sort? Because I have to say that while theoretically it sounds like something you should worry about, it's not something that we've found that we've had abuse to the extent that it's caused us a problem.
Okay, that's interesting to know. Thank you.
But yeah, don't set up your own, come to us.
I mean, if you're going to give it to us for free, then I mean, why not? Why wouldn't you do that? That's a great deal.